Okay, so this part here, what we're going to do is actually for the first part, unbiased estimate population variance, just use your calculator. Your cashier can do it also, so it's fine. What you do is actually just go to stats and then just key in the value. So just clear it as well. Then key in your values. Okay. So key in values, I think should be fine. So just key in 60, 65. Oh yeah, 65, 72, 90, 110, 180, 110, 180. Okay, then you have 11, 20, 32, 32, 10 and 6. Okay, can you calculate like that? Then after that, what you do is you just go to stats and just calculate this. All right, calculate this, edit. Maybe I should just go one variable stats, edit, calculate one variable stats. This part here. Key in list one, list two, calculate. Okay. And then you go to calculate. There you go. Your values are all here. So part one, your unbiased estimate population, this one, and this is unbiased estimate. Okay, so that's pretty okay. So GC. Unbiased estimate. 83. There you go. Not too bad. Part two, I'll just do it quick also lah. So part two. For part two, we have got just define let x be. Okay. Let x be the time students spend on their mobile phone per day. Then let mu, depending on the school, be the population mean time taken, time of time students spend on their mobile phone per day. That's it. Okay. So some school will require you to define the population mean, some don't. So it depends on your school. So just follow whatever is asked of you. So this H1 is mu equals to mu naught. H1 is mu naught equals to mu naught. Because they want defer, right? It's a two-tailed test. Defers just means not there. That's about it. So under H naught, the test statistic Vz equals to bar x minus mu over s squared over n 0 approx by CLT since N97 is large. Okay, that's it. Then after that, what we need to do is actually just use the classical method lah. I think classical method we all know already, so I'm not gonna like do this very in detail. So we already know this. Okay. So you want to reject. So reject H naught would just mean that you are rejecting on two tail, right? Zero and one, and then this will be 2.5%. It's 2.5%. Okay, uses 2.5% on the left lah. That's about it. So 2.5% on the left, you find the inverse norm. Second distribution inverse norm 3, 0.05 divided by 2. Okay, then left here. This will be minus 1.9599 minus 1.9599 1.9599. Okay, so reject H naught just means that Z stats will be Z stats so less than minus 1.9599 or Z stats is more than 1.9599. Okay, that's about it lah. So you just use your calculator minus mu naught and just solve for this inequality. Yeah, over 97 less than minus 1.9599 or 134 over 841.64. So this case here, hence bigger than 88.9. Less than 77.361. Okay, there you go. I think part 3 is quite okay. In context of this question, the solutions is below. Basically, the level of significance, right, is the probability of rejecting H now when H now is indeed true. So in context of this question would be, there's a 5% chance of concluding that the time spent on the mobile phone per day differ from mu naught when it actually did not differ. So means you say that, oh, it actually is not mu naught, but it is actually mu naught. Okay, so just take note of that. Part 4 is the one which I want to go through. Now, for part 4, I need to explain a bit. So let's follow me very, very closely. So if the null hypothesis in 2 is rejected, at 5%, what can we reject the null hypothesis at 1% level significance? Okay, explain why. So let me explain to you. 5%, if it's rejected. So I'm going to look at this. Let's just draw what does rejected mean. So this part here, we have got 2.5% and 2.5%. Okay, so when you're rejected, if you're rejected at 5%, it's like that. So the question now is, if you change this test, this is an alpha percentage. It's 5%. This is alpha percentage when it's 1%. Means this curve here would cut this side here. This area here would be smaller, so this is half a percentage, or rather 0.5%. This part is 0.5%. Okay, now if you reject H naught, one thing for sure, reject H naught, one thing for sure is your Z stat will be where? If you already reject H naught, your z-stat is actually either lesser than this boundary here, which we just now found, which is negative 1.95, and this is 1.95, right? So it's negative 1.95 or z-stat is more than 1.95, right? So let me explain to you. Z-stat can be anywhere here. So it could be anywhere here lah. So here, it could be here, it could be here. Um, as long as because you reject H naught means Z-stat could be here. It could be very, very at the end there or here, near to 1.95. It could be here. Anywhere lah, anywhere here, right? So the question now is, when you change the test statistics to a 1% level of significance, right? Would you also reject H now? Okay, so let's say if it's here, can you conclusively say that it will be within the 0.95% here? Okay, just so you know, when you do your inverse norm, right? Your inverse norm, right, 0.5%, inverse norm 0.5% is 0.01 divided by 2 on the left tail. Is actually a very, very, is actually minus 2.7, 2.5. So let's say this is minus 2.58, right? Obviously, it's not conclusive, right? Okay, it's not conclusive, right? So, obviously, this is not conclusive. You cannot conclude that it will definitely reject H naught when it's at 1%. So, how do you write? Since we reject H naught at 5%, this has a hold true, right? To reject H naught at 1%. Okay, we need z-stat to be less than minus 2.58 or z-stat more than 0.8, definitively. Thus, the test is inconclusive at 1%. Okay. You cannot tell whether z-stat is, because for all you know, z-stat can be 1.96, and 1.96 at 1% level test will not reject, so it's about here. Okay, so that's how you write if you want to use the z-stat way. The answer key for, they actually write in the p-value way. You can also write the p-value way. The p-value way is easier actually to write. So I will just write down method 1 using critical values method. Classical. Okay. Okay, I'll just pause here. Any question, can you please unmute yourself and ask? If you're not sure, just so for p-value method, it's actually much simpler to write. So method 2, p-value method. So what you write is test, right? Because you test H naught mu naught H1 mu not equals to mu naught. So you reject H now at 5%, right? This will mean that p-value is less than 5%. Okay, so p-value, it doesn't imply, this doesn't imply p-value is less than 1%. Hence, test is inconclusive at 1% significance level. Okay, so the p-value method is actually much easier to write. Yeah. So I will suggest anyway. We will upload this hub to the portal. Any question, just let us know. Okay. Okay.